In this video, we will see the TensorFlow. This is first video about the introduction of TensorFlow. So the TensorFlow website can be referred by using the URL tensorflow.org, and it is very popular library. So the TensorFlow is a Python friendly open source library, and it is mainly designed for numerical computation, which makes the machine learning faster and easier. The TensorFlow is a high-level wrapper above the highly complex mathematical functions related to the machine learning and deep learning. This is an easy-to-use method for the machine learning implementers to get the things done very quickly. So you can see the TensorFlow website here, and you can go through the various links. You can see how to install it, and there are various ways of installing it in different ways and different environments. Let's see it in practice. First example is related to the basic mathematics, basic mathematical functions and its implementation using TensorFlow. So we'll use the TensorFlow for the some basic operations on vectors, matrices and others. So first thing is to import the TensorFlow. It is assumed that TensorFlow is already installed in your environment. In case if it is not installed, you can install it for the latest version. Current latest 2.2.0 RC0, but you can check the available version and the instructions for installing it. So once the TensorFlow is installed in your environment, you can run it and you can import the TensorFlow library. We are importing TensorFlow as TF, and let's check the version, which version we have. The current version installed in my environment is 2.1.0. You can easily upgrade it by running this command, or you can work with the current available version. As this is an introduction, we don't need to upgrade it, but we'll see the same thing in the collab. Let us first create a 1D vector, one dimension vector. So you can do it by calling the tf.constant method, and by that you can pass the vector you want to create. Now tf, the TensorFlow creates everything as a tensor. So whatever is created here is a 1D vector, and tensor refers to an n-dimensional data type where you can have 1D vector or 2-dimension matrix or 3-dimension, 4-dimension database, and this is how tensor works. So v is equal to tf dot constant, and I'm passing the values 1.0, 2.0, 3.0, 4.0, 5.0. Observe that I have just skipped to write dot 0. It's not required, so I'm not writing them. And the first thing is to print v. Let us first comment this line, and let's see what exactly we are getting when we print the v. So while we print the v, we get the details about the tensor, as we have said that everything is stored as a tensor. So this is one tensor created by the TensorFlow, which has the values 1, 2, 3, 4 and 5. The shape of this tensor is 5 comma blank, and when it's a 1D vector, the 1 is not written here. It's obvious that its shape is 5 comma 1. The data type for this is float 32 because we have taken 1.0, 2.0 like that. So this is the first example where you can create 1D vector. Let us see what results are returned when we multiply v with v. So you can see that all the members of vector v are multiplied with itself. It's basically square of the value. So you get 1, 4, 9, 16 and 25. The shape is same and data type is float. Now let us create the 2-dimension matrix using the TensorFlow. So you can do it by using the same function constant, and I am creating a 2x2 matrix with values 1, 2 and 3, 4 in 2 different rows. Let us print this. I'll comment the remaining 2 statements. Let us print m. So it again shows me the similar output tf.tensor, and now it has created a matrix 1, 2, 3, 4, and the shape of this matrix is 2 by 2. The data type is also same, float 32. Similarly, you can create the matrix n with the values 1, 1, 0, 1. I have taken a random matrix for that. So now you have 2 matrices m and n, and let us multiply them using the matmul function. Matmul is used for matrix multiplication, so your value will be stored in mn, and let's see what mn shows us. So mn, as expected, shows another matrix which is a 2 by 2 matrix, and the values are 1, 3, 3, 7, and the shape is 2 by 2. The data type for this tensor is float 32. So this is how you can play with matrices. Uh, Next example is about creating the matrix using NumPy arrays. Now, if you want to create a tensor from the existing NumPy array, you can simply pass that NumPy array. So I'm creating the same matrix which I did in the previous example. Then I'm using a function called tensor dot. Now the tensor dot is a little different than matmul. Matmul is used for matrix multiplication, but tensor dot multiplies the values and returns a single variable. So t prod is the multiplication of t1 and t2, and let's see what t prod returns. That is 32.0. So if you multiply the values, it is 1 into 4, that is 4, plus 2 into 5, 10, 4 plus 10, and plus 3 into 6, 18. So in general, this will be 4 plus 10 plus 18, so you get 32. So this is the way it calculates, and if you want to convert it back to the NumPy array, you can simply do it by saying t prod dot numpy, and the value is 32.0. This is how you can play with TensorFlow. This was the way you have used in the Jupyter. Now let us see how the Google Colab can help you in writing the similar fashion. The Colab is another research product by the Google, and it can be accessed by writing colab.research.google.com. It requires a Google email ID for the access, and once you go to the URL, you can see some basic examples there, and you have to sign in first to run them. This is almost identical to the Jupyter, but it has different GUI and different controls compared to Jupyter. If you are familiar with Jupyter, you can easily get hands-on to this Colab node. The interesting part is you can see the usage because you are running everything on the cloud. So you have the RAM usage and disk usage of the account. So you can simply run the cells by pressing Control Enter as you do in the Jupyter, or you can run the play button and you can see the output here. Let's see a graph here. So this is a matplotlib example where you can show some interesting graphs. So again, you can run it from here and you can see the graph. It's changed to G. That's why it's showing green. You can play with the colors, different colors, and you can simply see the things in action. You may create your own notebook by clicking on New Notebook. It will create a notebook for you, and this will be the same IPyNB interactive Python notebook. And if you want, you can open your existing notebooks from your Google Drive, so it will show you the available files. And let's open this one. So it's there. The file is already open, and the things are same. You can create the text cells or you can create the code cells. So if you are creating text cell, you can play with its content. And if you are creating the code cell, it is almost identical as you do it in the Jupyter. So if you run here, you can get the TensorFlow library and you can check the version. So the version here is the latest version, which is 2.2.0 RC2, and what we are using in the local environment is 2.1.0. You can use the pip install to get the latest version, and this is the same example which we used in Jupyter. I'm just using the same function here, same data here, and I get the same results also. The interesting part here is while you are working on the complex examples, you can go to runtime and you can change the runtime. Basically, you are working on Python 3, so Python 3 is set as default, and for hardware accelerator, you can select GPU or TPU. So while working on the complex one, you can use GPU, and if you are not using the complex processing, you can avoid using this to save the processing power and the execution. Another interesting feature of Colab compared to Jupyter is that you can access all the files directly from here. Jupyter is installed in the local environment, so you can access all the files directly. But while this is on the cloud, so if you want to see the files, you can see all your files by clicking here. If you want, you can upload the files, you can mount the drive. So there are various options. We will use this feature later for some of the neural network applications. So this is how Colab can be used. It will be your choice to use either of them. You can use TensorFlow using Jupyter in local environment, or you can use the Google Colab if you do not have the local environment set with you. And if you are using Google Colab and you want to download the files, you can go to file and can download the notebook file, or you can download the Python file, whatever you want. Then you can put the same file in the Jupyter environment and you can refer it. So in the next video, we will start working with the different models of machine learning using the TensorFlow.